Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example on the test. Here in this particular question, we are given a function, f of x is negative 3x squared plus 2x cubed, and we have to use the following alternate formula to find the slope of the tangent line on f of x at the point x equals a and y equals f of a, right? So this is the alternate formula. Now, why they say alternate is because usually, mostly, most schools, most teachers, to find the slope of the tangent, and we've been using this one mostly, we use the difference quotient like that. But there is this other formula here that you can also use, and I have done examples with this one in the lecture videos just in case maybe your teacher is using this one. But you could use either of these and you should get the same solution. So we're going to be using this one, the circled one, but if you want to challenge yourself and maybe see how the algebra is going to be the same, or not the same rather, but the final result is going to be the same. The algebra is actually going to be different, right? If you were to use this one versus if you were to use this one. I've already done a ton of examples where we find the general slope of a tangent formula with polynomial functions. So same thing is going to apply. The expansion is going to be actually quite hectic because of this x cubed if you do it this way. But the final result that you should get if you do it this way should be the same as this one. But this particular question is going to be focusing on this formula. And then once we have that general expression for the slope of the tangent, also known as the derivative, which is going to be covered in the next chapter, once we have that general expression for part B, we have to find the coordinates where the tangent line is going to be horizontal. Now, when the tangent line is horizontal, that's another way of saying when the slope of the tangent is going to be 0, right? Because any horizontal line always has a slope of 0. So let's plug everything into this alternate formula. So we're going to have the limit as x approaches a of f of x. So we would just write this general function as it is. And you know what? I'm going to rewrite this so the degrees are in order like this. So this will be 2x cubed minus 3x squared, like that. So that's going to be the f of x, and then we're going to be subtracting f of a, which we just plug in a for the for the x values, right? So it'd be 2a cubed minus 3a squared, like that. And this is going to be all over x minus a, like that. So notice that we can't plug in an x value of a. We can't do a direct substitution because that denominator is going to be 0. And so what we have to do is somehow algebraically manipulate this numerator where we can maybe factor out an x minus a, and then the x minus a's would cancel out. Then we could plug in that x value of a in the remaining term and get our general formula, right? So that's what makes the algebra different than the other formula, because with the other one, you're just trying to cancel out a single h. Over here, there's this binomial term, x minus a, that has to cancel out, which makes the algebra fairly different. But again, the result should be the same. So for now, what I'm going to do, okay, let's distribute that negative here inside the bracket. So this would be plus 3a squared, like that, all over x minus a. And then what I'm going to do is I'm actually going to group this and this, right? Because they both have this coefficient of 2 in front, so we'll have 2x cubed minus 2a cubed. And then I'm going to group these two together. So I will have minus 3x squared plus 3a squared, like that. That's going to be all over x minus a. So then what I am going to do is for these first two, let's factor out a 2, so we'll have x cubed minus a cubed. So notice that that's going to be a difference of cubes there. One of the factors is going to be x minus a. And then from these two, I'm going to factor out a negative 3. So we're doing like a factoring by grouping here. And that's going to be all over x minus a like that. Now this x cubed minus a cubed, if you remember just in general, a difference of cubes, this is the formula, right? M minus n, m squared plus mn plus n squared, like that. So this is going to be x cubed minus a cubed. Let's factor it on the side. That's going to be x minus a, and then x squared plus ax plus a squared, I believe, right? Yeah, like that. Okay, so this bracket here factored into this. So this is going to be the limit as x approaches a. Here we're going to have 2x minus a, x squared plus ax plus a squared minus 3, and then x squared minus a squared, that's just a difference of squares. So x minus ax plus a. And that's going to be all over x minus a. And then as I mentioned, what's going to happen? X minus a is going to be able to get factored out. Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit. Number two, if you feel like you need tutoring at any point, I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go from both of these expressions. So we're going to have the limit as x approaches a. I'm going to take out that x minus a like that. And then let's keep it color coordinated. So 2x squared plus ax plus a squared minus 3, and then there we have that x plus a left over, right? X plus a, like that. So let's be super careful with all of our algebra. I don't think I missed anything, right? So I just took out this x minus a from both of these terms, and I was left with 2 in this bracket, and then minus 3 in that bracket. And now finally, the x minus a's cancel out as we wanted. And now what we can do is we could plug in an x value of a for all of the remaining expressions, right? So this would be a squared, this would be a squared, so this would be like 2 times a squared plus a squared plus a squared is 3. A squared like that, minus 3, and then this is going to be a plus a, which is 2a, which is going to give us 6a squared minus 6a. And that ends up being the answer for part A. That ends up being the general expression, also called the derivative, for our function f of x, right? So at any x value of a, this gives us the slope of the tangent on that function. And again, you could also try to get this with the other formula, the difference quotient, the limit as h approaches 0 of f of a plus h minus f of a all over h. When you do all the algebra with that, which is going to be very different from this algebra, final answer should be this 6a squared minus 6a. So now that we did part A, what do we have to do in part B? We're trying to find out when is the, or at what x values is the tangent going to be horizontal, meaning when is the slope of the tangent going to be 0 on this function right here. And so what would happen is we can then factor this, so 6a, and then we would have what, a minus 1, like that. So the two x values where that's happening is an a value 0, a value of 1. If you wanted to get the full coordinates, plug in 0 here. So this would be, if I plug in 0 here, I would get 0. And then if I plug in 1 over here, I'd get negative 1, like that, right? So those are the two answers for part B. That is basically where the tangent line is going to be horizontal. And where a tangent line is horizontal is usually at a max, a local max or a min on the function. Could also be a saddle point, but for this particular function, I think they would be max and min. So if you actually like graph this, what would happen, the way this graph would look like, is that it would bounce off at 0 and 0. So the 0 and 0 would be a max, and then there would be a min at over here at 1 and -1. Right? If you took this function and graphed it in Desmos, this is how it would look like. And so at these points here, the tangent is horizontal, like that. Or the slope of the tangent is 0, right? Just so you visually understand what's going on. Again, the drawing isn't necessary, but just so you get it, those are the final two answers for part B. At the coordinates 0 and 0, 1 and -1, the slope of the tangent of this function is 0. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.